Alright, so if I need to factor this polynomial, notice how it is a polynomial. It's to the has 4 terms. I recognize that I cannot factor by grouping. There's no GCF there. So we're going to use the rational roots theorem. Well, what do I need to do? Number 1, I need to find the factors of the first and last terms. So here's the first term. That's my 2 here. Factors of 2. And then the second thing I'm going to do is and then the second thing I'm going to do is the last terms. It must go in this order. So factors of 6. Okay? The next thing we need to do is divide each term. So I have plus or minus. Class, what are all the factors of 6? What are 2 numbers that multiply to be 6? 3 and 2. 1 and 6. Notice how I wrote those from least to greatest? Class, factors of 2? 1 and 2. Now we need to divide each term. I'm just going to pick 1 over 1, 2 over 1, 3 over 1, and 6 over 1. Do you see that? So that's going to equal 1, 2, 3, and 6. Now I'm going to do that with 2. What do I get, class? 1 half. 1. 2 over 2 is 1. 3 halves. And 6 over 2, which reduces to what? 3. Okay, number 3. Now we need to cross off duplicates. So I need to look at my list, and I'm saying to myself, any numbers repeat here? The 1, so I'm going to cross off only one number, and I see the 3's. Okay? So here is the fun of the rational roots theorem. I now need to test the binomials using synthetic division. Count with me. Ready, set, go. And what's 6 times 2? It is possible that there are 12 binomials that can actually factor to reduce that. That means I have to test it 12 times. Now, let me show you guys some hints. The first thing I'm going to do is I'm going to pick easy numbers. Everyone say easy numbers. So start with the 1. Let's do it. I have 2, -5, -1, and 6. And then I'm just going to use my synthetic division now. Bring this down. 2, multiply, add, multiply, add, multiply, add. Class, did I get a remainder of 0? No. So I'm going to make a note, not factor. Do you see that? Okay, I've just tested 1, but pay attention. I've tested positive 1. Let's test negative 1. We've tested 1. We got 11 more to go. The joys of math. Bring that down. 2, multiply, add, multiply. Did we get 1? Yeah. Everyone say yay. No. Do you want to test the other 10? Then say yay. Yay. We can almost stop. Here's the reason why I can stop. -1 is a factor. I don't have to test the other ones. Watch. Class, what binomial does that become? So we found one. If the remainder is 0, then use this binomial to factor. What does that become, class? X plus 1. What does that become? 2x squared minus 7x. Now you've reduced the cubic function or polynomial to at least now a quadratic, and can you factor that?
Yeah.
Yes, you can. Class, what goes in there? 2x what? Huh? Minus 3 and x minus 2. Okay. Now, notice I didn't have to test the other ones, but pay attention. Let me show you. X equals 1. X equals what? 2. I could have tested this number and got a 0. X equals positive 3 over 2. So of the 12, these were the 3 specific ones, but I only needed 1 to get the rest. And that's how I use the rational roots theorem to factor completely.